Hola, buenos días a todos. Les doy la bienvenida. Hoy tenemos una muy interesante conferencia, eh, el mapeo temático en el censo de eh, población de los Estados Unidos. Le doy la palabra a mi compañero Elio Villaseñor, quien hará la presentación de Kevin Hawley del US Census Bureau.
¿Qué tal? Buenos días. Voy a hablar en inglés para darle la bienvenida a Kevin. Hello, everybody. Today we have a very interesting talk titled Thematic Mapping at the U.S. Census Bureau, and it will be given by Kevin Hawley. I will give a short bio from him. Kevin joined the U.S. Census Bureau as geographer in 2005. He currently serves as the chief of the Geography and Products and Services branch in the Geography Division. His current work includes managing the production of maps, map services, and other cartography products to support data collection and dissemination efforts for census and surveys. Kevin holds a master's degree in geography from the Ohio State University with a focus in analytical cartography and geographic information science. Kevin, thank you for giving us this talk, and go ahead. The floor is yours.
Okay, sounds good. Thank you very much. Thank you for the introduction, and I'm very happy to be here today to discuss thematic mapping at the U.S. Census Bureau. You can go ahead and go to the next slide, please. All right, so the Census Bureau has a long history of mapping, including both reference mapping and thematic mapping. This presentation will focus on recent thematic mapping efforts at the Census Bureau and is not intended to provide an overview of all thematic mapping techniques. I'll be discussing the linking of statistical data to geographic data, the use of various thematic mapping techniques, including dot distribution maps, Coropleth maps, and proportional symbol maps, the use of interactive thematic maps, and best practices for thematic mapping. Next slide, please. When we link statistical data to geographic data, we're able to see the power of thematic maps. Thematic maps allow us to visualize the spatial distribution or pattern of a thematic variable. For instance, the table on the left includes tabular data about the percentage of the population in each US state without health insurance coverage, or the uninsured population. Our geographic data includes a geographic identifier, or a GeoID. And for state level data, the GeoID is a 2-digit FIPS code. So Alabama has a GeoID of 01, Alaska has a GeoID of 02, Arizona 04, and so on. We have GeoIDs for every type of geographic area that we tabulate data for. So this allows us to easily link statistical data with geographic data. When we create this link, we can see the resulting map. So this particular presentation of the data on the right shows a Coropleth map, and I'll be talking more about this later, with each state shaded based on the percentage of the population without health insurance coverage. So states in the lighter shades have a smaller percentage of their population without coverage, and the states in the darker shades have a larger percentage of their population without coverage. This illustrates the power of thematic maps. Next slide, please. The first type of thematic map that we'll discuss is the dot distribution map. Dot distribution maps may be a good choice if we want to show the distribution of a particular variable and the variable of interest as a raw total. On a dot distribution map, typically each dot represents, each dot does represent a static value. For instance, on a population map, one dot may represent 1,000 people, or on a cattle map, one dot may represent 50 cows. You can have a dot map that's a 1-to-1, but that's pretty uncommon. So typically the dot is going to represent some value that's more than 1. The dots are usually randomly assigned within the geographic unit they're associated with. And the data source scale and the data output scale are really important for this visualization technique to be meaningful. We usually want to have the source data available at at a fairly high resolution related to the map scale. And I'll describe that in a little bit more detail when I show examples on the next couple of slides. But with the dot distribution map, the cartographer controls the dot size and the value of the dot. And this technique provides the map reader with an understanding of the density and the distribution of the variable of interest. Next slide, please. This is a map showing the 2010 population distribution in the United States and Puerto Rico. The actual size of this map is 28 inches by 24 inches, so it is reduced quite a bit here. But this is one of our most popular maps, and we'll be creating a 2020 version of this in the next couple of months. It has the effect of appearing to be a nighttime map, as if taken from a satellite showing lights on at night. In fact, it's really just a dot map with each dot representing 1,000 people. In order to create this map, we start with population data at a very fine level of detail. We start with census block level data, which if you think like a census block, if you think of in like a downtown area, a city, it's basically gonna be what you think of as a city block. It's bounded by 4 roads on all 4 sides. As you get out to the suburbs, the blocks become larger, and then even larger as you get into rural areas. And they include, they're basically bounded by things like roads, hydrography, other physical features, and geographic area boundaries. So most blocks don't contain 1,000 people. So the program we use to create this map keeps a running total of the population, and once it hits the threshold of 1,000 people, it places a dot. So we're starting at a very high resolution of data in order to produce this map. Okay, next slide, please. This is a poster we put together that shows dot distribution maps for the 7 most common non-English languages spoken at home in the US. These languages include Spanish, Chinese, Tagalog, Vietnamese, Korean, Arabic, and Russian. And each language has its own dot distribution map. And for these maps, rather than starting at the block level like we did on the previous map, we use tract level data, and census tracts are closer to neighborhood size. They have populations of around 4,000 people. And for the resolution of this source data produces nice output for the scale of the map. So in reality, each of those individual maps is about the size of a page of paper, about 8.5 by 11. The tract level works well for this output scale. If we did this at, like, say, a county level as our source data, it wouldn't look very good. It wouldn't really have the look and feel that you get from this. So, okay, next slide. The next thematic mapping technique we'll discuss is Coropleth mapping. And Coropleth maps are some of the most common thematic maps. This is certainly the most common thematic mapping method we use at the Census Bureau. When creating Coropleth maps, we shade each geographic area, which is represented by a polygon, based on the value of the thematic variable. And rather than using raw totals such as total population, we use Coropleth maps to present normalized data. This could include densities, percentages, averages, medians, rates, and so on. For example, we wouldn't map total population on a Coropleth map. We map population density instead. We wouldn't map total income for everyone in the geographic area on a Coropleth map. We'd map the median income instead. For Coropleth maps, we present the data with sequential color schemes, which means we're going from a light color, which is generally associated with the low values, to a dark color, which is generally associated with higher values, for a single hue or multiple nearby hues. For example, if you think of shades of green or a color scheme going from light yellow to dark green, that's a sequential color scheme. We can also use a diverging color scheme if it's appropriate for the data, and I'll show an example of that in one of the following slides. The data on Coropleth maps are generally grouped into classes. We usually use between 5 and 8 classes on a Coropleth map. For example, the first class may include data from 0 to 9.9%. The second class would contain data from say 10 to 19.9% or something along those lines. So you can create unclassed Coropleth maps where the color is proportional to the value. These are generally more difficult to interpret, but they do provide more detail. For the US, we commonly use Coropleth maps to present data at the state and county levels for reports and briefs and things of that sort. Next slide, please. So this is a Coropleth map showing the 2019 median household income for the US and Puerto Rico at the state level. You notice the lighter blues on this map represent smaller median incomes, and the dark purples represent the larger median incomes. The color ramp progresses from a light blue to a dark purple. We also include state abbreviations on these maps. And one additional item that may be of interest to this audience is the inclusion of a circle symbol around the abbreviation for two states. Those are Wyoming and North Dakota, which are toward the top of the map. North Dakota is kind of top center. That circle around those state abbreviations indicate that the median household income is not statistically different from the US median in those two states. So you can add in information like that into a Coropleth map with other symbology like this. Next slide, please. This is a map showing the percentage point differences in home ownership rates between data sets across two distinct time periods. This is a bit different than a typical Coropleth map because we're showing the counties that are not statistically different between the 2 years in light gray. So this really allows us to highlight the counties that do have statistically different change across the two time periods. In addition, this shows positive change or increase in home ownership rates in shades of blue, and negative change or decrease in home ownership rates in shades of orange. So this type of presentation of the data, this is an example of a diverging color scheme. Percent change or data where you have positive and negative values is really a good example of a data set where you may want to use a diverging color scheme as opposed to a sequential color scheme. Okay, next slide, please. This is another example of a Coropleth map. This is a larger poster, so it is reduced in size a bit here. But on this map, we're showing the thematic variable that we refer to as the low response score, which is the predicted male non-response rate for the census at the census tract level. Again, tracts are more like neighborhood size in general. They have populations of around 4,000 people. This allows us to see sub-county patterns, and the shading here goes from a light yellow through darker green and finally into darker blues. The darker areas, which are those with a higher low response score, are the ones that we predicted to be harder to count in the 2020 census. Okay, next slide, please. Proportional or graduated symbol maps are another thematic mapping technique we can use. In the case of proportional symbol maps, the size of the symbol is proportional to the value of the thematic variable. In other words, a value of 100 would be represented by a circle with twice the area of a circle that represents a value of 50. So the size of the circle is directly proportional to the thematic variable. We can class the data rather than showing the symbol in proportion to its value. And in this case, we refer to those types of maps as graduated symbol maps. So proportional symbol maps do have their drawbacks in terms of readability. Humans are pretty good at judging differences in length or height, but not as good at judging differences in area. So they're more difficult to interpret than, say, a Coropleth map. The graduated symbol map can be a good option as the classified data limits the number of symbol sizes that one would need to differentiate on a map. So circles are the most common symbol choice for these maps, and we use these maps to show raw totals. Okay, next slide, please. This is an example of a map that was part of a larger poster. that shows proportional circles representing population growth over a nearly 100-year period. The green circles represent the 1920 census population of each state, and the purple circles represent the 2017 population of each state. Notice the legend, which is on the bottom right. It provides a series of circles with a call out line to the right that represents, that shows a number in millions. So those are basically sample circle sizes, so the user can get an idea of how large the population is associated with each state. So for example, if you look at California, which is on the left of the map, the fairly large circle there on the far left, California's 1920 population of around 3.5 million is represented by a small green circle, which is, if you look to the legend for comparison, it's in terms of size, it's right in between the 1 and 5. It represents 3.5 million people. California's purple circle, the 2017 population, which is close to 40 million, is represented by a large circle that's roughly the same size as the largest one on the legend, which is 40 million. So this is how the reader can understand the size of the circle on the map is through a legend like this. Next slide, please. This was one of the 3 maps we released recently as part of our 2020 census apportionment release. It's a very recent example of a graduated circle map showing 2020 resident population in the US and Puerto Rico. Notice in the legend, which is on the top right here, it shows ranges of data represented by each circle rather than the actual values. So that's what makes this a graduated circle map. So we classified the data into 5 classes. So the reader only needs to differentiate between 5 circle sizes on the map instead of 52. Okay, next slide, please. Online interactive maps have become much more widespread over the last couple of decades. In recent years, we've been using this technology quite a bit for both internal and publicly available applications. It allows the users to see data at various scales, which opens up opportunities for the cartographer to present data at various levels of geography. For example, we can display state level data for small scales, county level data as the user zooms into medium scales, and tract level data as the user zooms into larger scales. This technology allows for pop-ups to appear when a user clicks on a geographic area, or if they mouse over a particular area. We can use the pop-ups to show things like the raw data, the calculated values, names and codes, or other information that would be useful to present to the user. Web services may allow a user to extract data from an application or use the web services directly in their own application. We can also allow users to make decisions about the data classification, such as the number of classes, the type of classification, the colors, things like that. Next slide, please. So I'll be showing some examples of some of our web maps or web map applications that we have available to the public. This is a screenshot of one of our interactive web map applications called the Response Outreach Area Mapper, or ROAM. And ROAM displays the low response score, which is the predicted male non-response rate at the census tract level for all tracts in the US. A user is able to click on a tract to see additional information about the tract, such as income data, age distribution, race distribution, language spoken at home, renter occupied versus owner occupied, and so on. Users are able to pull up the data table from within the map and create filters based on various criteria. And ROAM was used for the 2020 census to create a tailored communication and partnership campaign and to plan field resources, including hiring staff with language skills. Next slide, please. This slide shows a screenshot of our 2020 census non-response follow-up, or NRFU, operation viewer. NRFU is a 2020 census operation where field staff visit households of those who have not yet responded to the census. And this interactive map was updated daily during the NRFU operation. This screenshot is from data on September 3rd, 2020, before the operation was complete. And the lighter shades on the map indicate the areas with lower percentages and lower percentages of the operation complete, and the darker shades represent areas with higher completion rates. Okay, next slide, please. This is a screenshot of our 2020 mail contact strategies viewer, which shows various categories of how we contacted households to respond to the 2020 census. So areas in the purple shades represent internet first households. Internet first basically means we sent them invitations to respond to the census via internet. And the areas in green shades represent internet choice areas, or the areas where we sent both a paper form and an internet invitation, and they had the choice of how they wanted to respond. Darker shades of both colors represent areas where we sent bilingual Spanish mailings. And this is a categorical thematic map rather than a quantitative thematic map. Okay, next slide, please. This is the historical apportionment data map, which was released by our communications directorate as part of the 2020 census apportionment release. And it includes historical apportionment data from 1910 to 1920, or I'm sorry, 1910 to 2020, and represents the apportionment and population data as a map and in charts and graphs as well. You can see the decennial years listed on the left-hand side of the menu, and users can select any of those years to see the results of the apportionment process. And they can also select a state, and the charts and graphs will update with data specific to the state of choice. Okay, next slide, please. This is a screenshot of our new data dissemination engine that's available at data.census.gov. Within this dissemination engine, we have mapping functionality, and the map functionality allows users to select geography on the map and to create thematic maps based on the selections of geography and a variable of interest. On this slide, the user has selected all counties in the state of Pennsylvania, and the variable of interest is the median household income. So users are able to customize some things on the map. If you look on the left-hand panel, you can see that they're able to customize the number of data classes, the classification method, and the color palette. Next slide, please. Okay, so now we'll talk a little bit about some best practices for thematic maps. First, we want to make sure that we're using a thematic map technique that's appropriate for the data. And when we're mapping quantitative data, we want to make sure that we use quantitative color schemes. So the legend on the left here, which shows percentage without health insurance coverage, this is using a sequential color scheme. This is an appropriate color scheme for a quantitative map as the class progresses from lighter colors for the lower values to darker colors for the higher values. The middle legend is another appropriate presentation of quantitative data. This is using a diverging color scheme. Again, this works pretty well when you have 0 as your breakpoint, if you have positive values in one direction, negative values in another direction. In this case, we're using shades of blue to represent the positive change and shades of orange to represent negative change. And then the third legend type here is what we really avoid. This is a rainbow color scheme, and these really should not be used at all for when you're mapping quantitative data. It's different difficult for a reader to perceive patterns with a rainbow color scheme, and it requires constant reference from the map to the legend to understand which colors are higher or lower in value than others. We can naturally interpret a sequential color scheme like the one on the left, as we associate lighter shades with less and darker shades with more, but we don't naturally interpret rainbow color schemes. It's not intuitive that the red color on this legend would be more than the purple, or that the purple is more than the blue. So we want to avoid these sorts of color schemes from quantitative data. Next slide, please. Legend design is very important for communicating with maps. Legends should be clear and easy to interpret. They should include a legend title, non-overlapping classes, and distinguishable symbols. It's important to establish layout guidelines in organization. For example, on Census Bureau maps, we always want to include Alaska in the top left of the map and Hawaii in the bottom left. This keeps them in their relative positions in relation to the 48 contiguous states. Another example of layout guidelines relates to the District of Columbia, or DC. DC is a state equivalent, but it's very small. So on page size maps, like on a typical 8.5 by 11 page size map that shows state level data, we will show an enlarged version of DC off the East Coast of the US with call out lines going from its actual location to the call out location. We only do this when we're showing state level data. We wouldn't do this for county level data because there are other counties. DC serves as a county equivalent as well as a state equivalent, but there are other counties that are as small as or smaller than DC. So we really only do that on the state level maps. Another layout guideline would be to establish whether to include scale bars and north arrows. Scale bars are not required on thematic maps. We do include them on some thematic maps, and it's essentially just to provide an indication of scale, and we make them very simple scale bars, not ornate scale bars. Same thing with north arrows. They're not required for maps that show highly recognizable areas in the normal north orientation. So, for example, the shape of the United States is very recognizable, and we always present national maps in that north orientation. So we don't really need to include north arrows on those. But when we create more localized maps, we do generally include a north arrow because the reader may not be familiar with that area. The vintage of the boundaries on the map should match the vintage of the statistical data. And the boundary files should provide an appropriate level of generalization. Generalization is a process that removes detail. So for example, on a page size map of the US, the scale is about 1 to 20 million there. So we use boundary files that are generalized with a 1 to 20 million scale in mind. This removes a lot of extraneous points that would create visual clutter otherwise. We create what we call cartographic boundary files or generalized boundary files at scales of 1 to 20 million, 1 to 5 million, and 1 to 500,000 for mapping at various scales. We also want to make sure that we're projecting our data onto an appropriate map projection, and we use equal area projections for our static maps. Next slide, please. Okay, so this is a recent example of a suite of maps that we released with the 2020 census apportionment release. The first map shows the change in the US House of Representatives seats based on the 2020 census. So states that gained seats are shown in shades of green, and the states that lost seats are shown in shades of purple, or shown in purple because there's only one category there. On the top right is the graduated circle map that you saw on a previous slide that shows the total resident population. And the map in the bottom right shows the percent change in resident population, where the increases are shown in shades of teal and the decreases are shown in shades of orange. Next slide, please. This is a really neat map poster that we created for Veterans Day several years ago. It includes a dot distribution map as the main map in the middle of the page, which shows the distribution of veterans in the US and Puerto Rico. And then around the edges, you can see various smaller Coropleth maps, highlighting data such as education and income for the veteran population at the state level. It also includes charts highlighting military service and employment status. Next slide, please. This final example is one of the maps within our most recent suite of statistics and schools maps. We made wall maps for classrooms in the US, Puerto Rico, and the island areas. This is the wall map that we produced for the Puerto Rico high school classrooms. The top map, or the main map on this poster, shows population density at the municipio level as a Coropleth map. On the bottom right, we have a proportional circle map showing the population 15 to 19 years of age, and a Coropleth map showing the percentage of the population 25 years or older with a bachelor's degree. This poster also includes a line graph showing the change in population in Puerto Rico from 1910 to 2010. It has a population pyramid, and it also has a locator map. Next slide, please. So I'm also going to provide you here with some useful links to some of our Census Bureau resources, specifically map and geography resources. The first of these links is our geography homepage, which provides links to products, reference materials, and other information about census geography. The second link is for a visualization page. So this is where you'll find thematic maps and other data visualizations that are made from throughout the Census Bureau. We also have a link to our reference maps page here and our cartographic boundary files. The cartographic boundary files, those are those generalized spatial files that we use for thematic mapping, so they have less detail than our full resolution files. And finally, the tiger line shape files, the last link here. This is our full resolution spatial files. So these are all of our boundaries and roads and hydrography at their full detail, full level of detail. So this is the end of my presentation. So thank you very much for your time, and I understand we'll take some questions now.
Thank you, Kevin. And I guess we have a lot of questions. I remember you that you can put your questions in the chat box of the meeting. And I would like first to make some questions related to what it takes to make such great maps. How big is your team? How many people are involved in this process? I mean, what are their expertises? I can imagine that is a multidisciplinary team. All about related the people behind what you just showed us.
Yeah. So in terms of the actual cartography, the mapping side of things, we have my branch has 15 members right now. And that's essentially our fully staffed level is 15 members, but we're part of a much larger division, the geography division, which has I want to say it's around 200 or 250 people in the division, and then we also work closely with other areas, our IT support areas. There's a fairly large number of folks over there that we work with that support our database, that support our any software that needs to be written and things like that. So overall, it's a large number for the geography side of things, but from the mapping side of things, it's a smaller number. We have about 15 in our branch.
Yes, and you do a quite great job. And related with the technological framework you used, I saw that you use already Esri, but I don't know if you are using another software tools that are needed to get these maps.
Yeah, so most of the actual mapping that we do is done in the maps that I showed today, the thematic side of things. Those are mostly done in ArcGIS. We do some of them in ArcGIS Pro, and the interactive maps, the web applications. Those are done using Esri server, or it's Esri Enterprise server, and Esri Portal. So we have our own instance of Portal, which is very similar to ArcGIS Online. It's just that it's inside our firewall, so we kind of manage it and own it. So that's what we use for those. We do a lot of mapping in a system that was developed in-house. It's called CAMPS, the Census Automated Map Production System, but that is mostly, well, almost exclusively for reference maps. We don't do thematic maps out of that system. Our database, our MapTiger database is in Oracle. So there's a lot of people that have Oracle skills, essentially to be able to extract data. We will use something called Feature Manipulation Engine, or FME, to extract data from our Oracle database into shapefiles, geodatabases, things of that sort. So I would say those are our main tools: ArcGIS, Oracle, Esri products. There are some in geography division that are using it's one of the open source GIS softwares, which I can't think of the name of right now. But from the mapping standpoint, it's mostly ArcGIS.
Great. And before I go to the questions for the audience, I would like to ask you if you have tried to make in the interactive maps you show us to give the user the possibility to make a clustering analysis based on multivariate data to get a stratification of the counties, or based on clustering analysis.
No, we haven't really done a whole lot with clustering analysis. We mainly present the data as it is and don't do a whole lot of on the analytical side of things. It's more we're usually creating maps to support, say, a report or a brief or some sort of data release. And so we're typically just taking the data, classifying it, and putting it out on the map as it is, and not doing the analysis as much. So.
Great, thank you. Well, I go to the questions from the audience. We have the first one from Jocelyn Ceron, and she asks, what is the smallest scale or geographic unit that you use to recollect your data?
Yeah, so on the data collection side, we have something called a BCU, which is a basic collection unit. It's similar to a tabulation block or a census block, but there's really an emphasis on visible boundaries, things that people can see in the field for the delineation of the BCUs. So to give you an idea, across the entire US for the 2020 census, we had about 5.5 million basic collection units, or BCUs. So that would be the smallest collection unit that we have. On the other hand, the census blocks, or the tabulation blocks, the ones that we tabulate and put data out for, there are about 8.5 million of those for 2020. So those are smaller than the collection blocks. But again, the collection blocks, since we want to have something around the edge of those that can be seen on the ground for the most part, there's less of those. So.
Great. We have a question from Eric Rodriguez. Do you have a map dissemination program with different types of users? Are there maps designed for elementary school students?
Yeah. So the one program that we do have that incorporates like different age levels and grade levels is called the Statistics in Schools program. So that last map that I showed of Puerto Rico, that was part of the Statistics in Schools program. And for that, we created maps of the US for elementary schools and then middle schools and high schools. So 3 different maps for those. And then for Puerto Rico and each of the island areas, we created, I think for Puerto Rico, we did both an elementary / middle school and then a high school map. And then for the other island areas, I think we did a single map. I'd have to go back and look because it's been several years since we did those. But that program really does target, younger age of users. Typically, when we put out a map, we're just, putting it out for the general public and not targeting a specific age, except for within that program.
Great. The next one is from Mara and asks if it is possible to share the links you show us in the presentation, but actually I understand that all the slides of your presentation are available in the seminar website. And if Rodrigo, please put the link in the chat to everybody. Irving Cabrera is asking, which are your favorite tools, frameworks to create visualizations?
Yeah, I mean, I like, because I'm familiar with it, I like ArcGIS. And ArcGIS Pro, we're starting to work with a lot. We use ArcGIS Pro a lot for our like our web map services. We're starting to use those pretty much exclusively because they render a lot better. So the fonts look better, the colors look better. The line work is much finer and crisper. So I tend to be on the ArcGIS side of things. We do have a lot of work that goes on in the Census Bureau where they use Tableau. From a mapping perspective, we've had a lot of challenges with Tableau, but we work with those teams that create those visualizations to create a product that will meet our standards. So, yeah.
Yes, there are other questions related to the software, and you already answered them. Regarding, well, we have a question from Yasu Coronado regarding best practices for using inadequate thematic maps for the data. Do you think it would be recommendable to use some advanced statistical techniques to illustrate census data? For instance, mapping an index generated through principal components. Which other techniques do you think it would be appropriate?
Yeah, I mean, I think there's a lot of interesting stuff that can be done with statistical techniques. One of the maps I showed, the low response score, that is basically a statistical model that creates those low response scores, and then we map them. So the statistical model essentially predicts at the census tract level what sort of response we're going to get from the people that live in those households, and it's all based on just various variables and input data. So I think those sort of techniques are very useful, and especially as data science continues to grow, things like that, we'll probably be seeing more of that.
Great. Well, Alejandro Hinojosa asked us, I can imagine to INEGI people, if we have something similar in Mexico, and I can answer yes. We have some similar products. We have the CINCE, for example, that shows the census data in an interactive way, and yes, we have something similar. Very practical. well, you have quite good comments related to your presentation. Very practical examples, useful. Thanks for sharing your experience, etc., etc. Ricardo already pasted the link for the material that you just show us. Another question from Johamin Soto. Do you find open source programs useful?
Yeah, so I would say within the geography division, we definitely have. My area in particular is not using much open source, but the geography division did use open source to develop some partnership GIS tools for the 2020 census. We also did use some open source databases for some cloud deployments for the 2020 census as well. So there's definitely some open source use, and we found some things that are that have worked really well. But within my particular area, not so much.
Great. Well, we finished with the audience questions. If you have any other questions, please put it into the chat box. I would like to ask you another question. When I asked you related to the clustering analysis in visualization, you say something very important and clear. You say that you don't want to put in the maps something that is not in the data or explicitly in the data. And I wonder if you have tried to use a grid-based map, I mean a regular grid, and to visualize data and aggregate data based on a regular grid. Have you tried this?
Yeah, that's something that's been talked about for years at the Census Bureau, and I think it is something that we'll be doing. I would say over the next decade, we're definitely going to be doing research into that to see if that's something that we'll move forward with. So.
What are the advantages that you have find to doing that?
Well, I think the main advantage is that it would be an international one, in that each country has sort of their own geographic areas that they present data for, and they're not necessarily they don't necessarily mesh well together when you try to put down data sets from all over the place. And I think a lot of international sort of collaborations are interested in gridded data, because you can have a constant resolution throughout the world to analyze data. So I think that would be kind of the main reason behind it.
Great. We have.
Do you do gridded data in Mexico?
Yes, we are experimenting with that. We find it very interesting and useful for some purposes. Yes.
Yeah, I think one of the main things there is some grids are based on longitude and latitude, and that means each cell is really a different size. If you use say a grid of the same distance in latitude and longitude, then you get varying areas depending on where you are on the Earth. So one thing to consider is it probably makes more sense for the grids to be the same size. So essentially you could create a grid using like an equal area projection, create the grid off that, and that would keep each cell the same size. So I don't know. That's probably something we'll be looking into.
Yes, definitely. Well, we have another questions from the audience. Andrea Villavicencio asks if we need to be a data scientist to do this job.
If you need to add a data scientist to what? I'm sorry.
To do the job you just show us.
Oh, Yeah, well, I would say that data science has kind of taken off at the Census Bureau, and we have a training program for it, and we have people involved in it, and it's definitely got legs. So.
Great. We have another question from Alejandra Figueroa. In your opinion, what is the maximum number of different values, colors that should be presented on a map?
Yeah, this is a really good question. You know, the literature sort of points to 8 as a maximum, especially if you're using you know, one shade or too closely shaded. We found that, you know, if you're doing like a diverging color scheme, which would be the one like the example I had where you go in blue for positive values and orange for negative values, something along those lines. Since you're really using 2 sort of distinct schemes, you can really probably get away with 5 in each side, and that would be 10 total classes. But you know, we try not to go over 8. It just becomes pretty difficult for people to differentiate which class is which. So 5 is kind of our starting point usually, and if it seems like we need to create more classes, we'll go to 6 or 7 or 8, but we try not to go above 8. So.
Great. We have another question from Oscar Alejandro Esquivel. In order to understand the volume of data that this map use, do you manage massive data?
Yeah, the geography division, along with our IT support, manages a huge database called the Math Tiger database. It has all of our geographic area boundaries, all of our roads, hydrography, points of interest, along with all of our addresses. So it's several terabytes, and I'd say twice a year in general. Decennial years are a little bit different, but for the most part, every year we do what we call benchmarks twice a year. So we take a snapshot of our database at that time, and then we create all of our products from that for that time period. And so that benchmark gets stored also, and that's managed as well. So you know, we have benchmarks in Oracle going back since 2007. In storage, so it's a large amount of data. For the maps that we're producing, we're usually, you know, extracting some portion of that database. So we're usually not dealing with the entire database, but there are things that are very data heavy, especially when we create like base maps, like vector tile base maps and things like that. That can take you know, 5, 6, 7 days of 24/7 processing to create that. Yeah, it can be pretty intense with the data sizes we're using. Yeah.
Yes, I could imagine. We have another question from Yasu Coronado. Do you use Python language in combination with GIS to create your maps?
Yeah, we do. We use Python whenever we have to automate for create a large number of maps that we wouldn't want to do manually, that we're not going to do in our other system, which is called camps. So it's kind of hard to make that determination. Let me give you an example for the 2020 census in the island areas. They're still full paper. They didn't have, you know, devices out in the field. They used paper maps. And one of the things that they wanted to do differently for 2020 from 2010 was have a paper map that had imagery on it, so that they're not just seeing the lines on the map and the names, and a lot of names in the island, or a lot of the roads in the island areas don't have names. So they wanted some more context there. So they wanted to have imagery in the background. So that was the basic collection units in the island areas, which we talked about earlier, the BCUs. There were 5,500 of those. So for each BCU, we had to create a map with imagery in the background. And so we automated that process, and we used Python to do that. So basically just kind of worked in the ArcGIS environment. The script would basically zoom from one BCU to the other, create an output, a PDF output of it. And it did that 5,500 times. So yeah, that was, we did that recently for, to support another 2020 activity where we needed to create some maps really quickly for about 200 entities. And we were able to work that out pretty quickly, so.
Great, great. Thank you for sharing this experience. We have another question from David. Besides Oracle, do you recommend other databases engines?
I don't really have much experience with anything except for Oracle. So yeah, so I can't make any other recommendations.
Okay. Well, we don't have more questions. I just want to make a last questions from myself. You show us an example of a map that shows these things, times, data from distinct moments. I don't remember, it was 2010 or 2020 or something. No, 1920 and
1790 or 1920 yes. and 2017. Yep.
Yes. And you show us a map with circles and that was a very good resource to show the change, but I don't know where, I am not very sure if it is possible to do this with more times, more points in time. No, I mean, and what would you do if you have to make a map that shows a dynamic in time with more time frames?
Yeah. Yeah, I kind of think the best option for something like that is like an animation, or like, some sort of like interactive type of thing. One thing that I know Tableau does fairly well, and we have some examples of this. I could send one of these over to you. My area didn't do it, but one of the other areas did. And it shows, I want to say it's about 8 or 10 different time periods of health insurance coverage. So it's a Coropleth map, and it shows the data in, like 2009. Here's the percentage of the population in each state that doesn't have health insurance coverage, and then it sort of just cycles through, like every, I don't know, 3 or 4 seconds. It goes to the next time period, and you can control it interactively also. So you could stop it if you wanted to pause it. But it just kind of goes through to from year to year to year. So you can see that change. The real important thing there is to make sure that your legend is consistent throughout. So you need to have the same class breaks in all of those years for that to be a meaningful visualization. But yeah, that would be my recommendation there. I think if you tried to do that with a lot of time periods, with like the overlap with multiple circles, it would probably get pretty confusing. So yeah, so like an animated approach would probably, it would be a difficult thing to do on a static map, I would say.
Well, thank you very much. We are running out of time, and it was great. I think that it was a very, very good session. We have a lot of questions, a lot of interest from the audience, and a very good talk from you. Thank you, Kevin.
Great, thanks a lot. Bye.
See you.
See you.
Thank you very much. We're now out of time, but our next conference will be on June 21. Dashboard says statistical output from Statistic Netherlands. So please join us. Thank you.